Hello, you're welcome back. All right, so we're still on logarithm. So here I have another subtopic. Okay, so we're going to be looking at the substitution and logarithm. Now, how do we do that? Okay, now let me give you a typical example. Let's say situation. I'm being given some log, right? Let's say I'm being given log of 2 in the base of y to be equal to 3. Okay, to be equal to, let me call it z. Okay, let me call it b, right? And I'm being also given log of 3 to the base of y to be b, right? So now the question is, with this being given, right, I'm not asked to evaluate a log of 12 in the base of y, b log of 45, okay, log of 18 to the base of y. C, okay, let's say I'm also being given the log of 9 to the base of y. So now substitution, we actually apply substitution in logarithm. Okay, if you are being given some log, the value of some logarithm, okay, and they are being asked to evaluate a log that you need to substitute what you are being given into that log. As you can see here, I was only given log 2 in base y and log 3 in base 1, but I'm to evaluate this log in base y. So all I just need to do is to express this log in terms of log 2 and log 3 so that I can substitute, right? So now, solution. Now starting with the very first, which of course is log of 12 in the base of y, right? So how can I express 12 as a factor of 2 and 3? It's easy, all right, because we know very well that 12 is 2 times 3 is 6, right? Okay, 2 times 2 is 4, right? And of course 4 times 3 is 6 in base y. So that's what I just did. And now transform 12 into the factors of 2 and 3, because my log, the log that was given, okay, is only log 2 and log 3. So I have to transform 12, okay, into the factors of 2 and 3, right? So now the question is, how do I now separate them into their different log, because they are just in just one log, only one base, okay? Because I cannot substitute here. This is log 2 times 2 times 3, okay? I have to separate it into their individual log. So now remember our multiplication law of logarithm, all right? This is, I'm going to go through the reverse process of the multiplication law of logarithm. Remember, in logarithm, once you have addition of log, it leads to the multiplication, right? But this time around, I'm going to go, okay, to the reverse, okay, process of what led to this, and that is going to be log 2 in base y, remember, then plus log, okay, log 2 in base y, then plus log 3 in base y, okay? Don't forget it was this, when you evaluate this, that actually led to this, okay? So having splitted the logarithm into individual log, so I can now do, okay, I can now substitute, right? So remember, log 2 in base y is a and log 3 in base y is b. So what I'm going to have here is going to be equal to, this is a, right, plus this is also a, then of course this is b. So this gives me 2a plus b. As simple as that. All right, let's do the same for log 18, the b part of the question, right? Is that the b part? Excuse me, yeah. For log 18 in base y, so how do we go about this? So what is 18? Of course, 18 is 2 times 3, right? Which of course is 6. 3 times 6 times 3 is 18, okay? Which of course is log 2. This, pardon me, in base y, not base 2. Alright, y, right? Okay, so let's flow. So that's gonna be log 2 in base y plus log 3 in base y, then plus log 3 in base y. Alright, so log 2 in base y, of course that's a, right? Then log 3 in base y is b, log 3 in base y is b, so my answer is gonna be a plus 2b. Alright, so I believe that you could actually do this. Alright, it is easy. Of course this is 2b, right? So that is it. Then the next thing we're going to be looking at, okay, is the equation and logarithm. Log equation, okay? Equation and logarithm. Now, an equation and logarithm is simply, alright, an equation that has log term in it. And it's very easy to solve. Okay, to solve equation and logarithm, you still apply the laws of logarithm. So I'm going to give a typical example. Okay, a typical example of equation logarithm. Let's see a situation where you're being asked to evaluate a log x plus 3 in the base of 2 minus log 5 in the base of 2 equal to 1. Okay, so I hope that is well understood. Okay, so let me look at another question. Let's say a situation where you have been given log 2x minus log x plus 1 all in base 3 equal to 2. Alright, so let's solve. Solution. I'll start with a part of the question. Now, for me to evaluate this equation, first of all, I need to simplify the right-hand side. And of course, you know, this is division law, right? I have to simplify it. So this is going to be log, okay? Of course. Okay, so please pardon for that. Pardon me for that little break. All right, so now I'm gonna continue. So I'm applying division law. Remember, the minus actually use division law, right? Have 2x all over x plus 1 inverse 3, okay, equal to 2. Now the question now is, how do I eliminate this log? How do I eliminate the log? Okay, now for me to actually eliminate this log, okay, I'm gonna show you because I need to eliminate the log, okay, so that I can, okay, let me write this well. Let me write this well so that, okay, so this is 2x, right? 2x all over x plus 1. Let me put it in a bracket, right? Then of course put the base. So now the question, how do I, when I want to find x, so I want to take away the log out so that I can rearrange the equation to get my x. So for me to eliminate this log, definitely I have to actually take 3, okay, to the other side to evaluate its exponent. Or, okay, I take, okay, let me actually put it in a way you understand, okay. Take 3 as the base of index at both sides of the equation. Okay, I believe you understand what I mean, but I will explain. Take 3 as the base of the index, okay. Now let's say I have 2 here, then I have log 3, okay, log 2s all over s plus 1 inverse 3, okay. Now if I want to eliminate this log, I'm gonna use 3 to raise the log, this log to a power, right? So that's what I mean. So what I'm gonna do now, I'm gonna do 3 raised to the power of log 2x all over x plus 1, then inverse 3. So the whole idea is that anytime 3 raised to the log of the same base, when you take an index, okay, to the power of log of the same of the base, okay, of which the base is still the same index, all right, so what happened? Definitely the log cancels out, and whatever I do to this side of the equation, I also do to this. I will come back to this particular law, okay, so that you understand it. So I also take 3 as the base of the index of the both sides. So what actually happens then, you know what happens here? 3 cancels the log, so I'm only left with now 2x, right, all over x plus 1 equal to 3 raised power 2, which is 9. So I can cross multiply now. I can cross multiply. I have 2x equal to 9 so this is going to be 2x equal to 9x plus 9, right? Excuse me, rearranging the equation, you know what we do? So I can take this to this side, take 2x to this side of the equation, take 9 to the other side, or vice versa, right? So I can do this. Minus 9, all right, is equal to 9x minus 2x, right? And 9x minus 2x, and that gives me 7x, right? So I have minus 9 equal to 7x. So my x invariably now is gonna be equal to minus 9 all over 7. All right, so that is just it. Now going back to the law I just, this is actually a law, right? If you have a raised to the power of if you have a raised to the power of log of m still in base a, definitely this goes, okay, cancels out, right? Or it becomes 1, then you're left with just m. So this gives you m. So please take note of that. If I have b, okay, let's see, if I have 2 raised to the power of log, okay, 3 in base 2, my answer will be what? 3. So now the tutorial that are actually, okay, delicate for the proof of laws, I think I will also prove this law, right? I'll prove this law. There's gonna be a video for the proof of laws of logarithm, so please take note of that. Okay, so now let's not solve the B part of the question. Okay, so I hope you're with me. Okay, now here we go. B, we do the same thing. The one I solved was what? I solved B instead of A. Alright, now I'm solving A. Okay, alright, I don't know if I made a mistake, but let me solve A. Okay, so the same thing goes for A, right? I'm gonna have log division, this division law, right? S plus 5 divided by 5 in base 2 equal to 1. Right, so you know what to do now. This is gonna be 2 raised to the power of log x plus 5 divided by 5. Don't forget the base 2, and also do the same thing. Okay, take this 1 as a power. Alright, so this is gone, so I'm left with x plus 5 all over 5, right, equal to 2 raised to the power 1 is 2. If I cross multiply, I have x plus 5 equal to 5 times 2, that's 10, right? So now my x becomes 10 minus 5, which is 5. Okay, so I hope that is well understood. Okay, so in this tutorial, we're going to be looking at some other questions, okay? Miscellaneous questions. And of course, I'll be getting it from a textbook, right? Okay, so I have a question here, then we're going to do justice to it. Okay. So, example. So this question goes like this, okay? If log 3 in base y is equal to a, comma, and we are also being given another log, which of course log 5 in base y is equal to b. So now the question is proof. Proof that when you evaluate log 81 in base y, right, then the plus log 1125 in base y, and minus log 1 all over 15 in base y, your answer should be equal to, it should yield 7a plus 4b. So this is what this question is actually asking us to do is to, okay, resolve this, alright, and to show after resolving this you should have this. That's just a very simple thing that you are doing, okay? So, and of course, you know, this is substitution and log, right? So we are using this log to substitute into this, and of course you know how we do that. So I will simply express all this log in terms of log 3 in base y and log 5 in base y. So how do we do that? Let's look at log h1. starting with log 81. Okay, to make it easy, 81 is simply 3 raised to power 4 in base y, as simple as that. Then for 11125, I think this should be in powers of 5. Let's calculator will help us now. Let's get a calculator, okay, so that we do the right thing. Okay, let's see to which index I'm gonna raise a number, right? To which power I'm gonna raise a number to have 1 okay. Okay, let's 1 let me bring the calculator so that you see it. 1125, right? 1125. Let's divide by 5. I have 225, right? Divide by 5 again. I have 45. That is 5 raised power 2, okay? Divide by 5 again. I have 9. So I have 5 raised power 3 then times 9, right? Okay, 5 raised power 3 times 9. So 5 raised power 3 times 125 times 9, right? Okay, or better still, then I have 9, right? So I can write this log 1125 as log 5 raised power 3, or 5 times 5 is still the same thing, right? Times 5 times 5. Then times 9, which of course is 3 times 3 in base y, right? Then minus, let's do justice to this. So this is going to be log 15, all right? Yes, 15 is 3 times 5. This one over 3 times 5 in base y. All right, so we can apply our laws, all right? So this is going to be, first of all, it's going to be 4 log 3 in base y plus, this is 555, okay? So it's 5 raised power 3. So I can simply do 5 log, all right, excuse me, pardon me, 5 raised power 3, okay? So the power is 3, that will be 3 log 5 in base y. Then for 2, don't forget that I'm splitting the logs now, all right? I have to split this using plus, cause of multiplication. Don't forget what we normally do, okay? So I'm actually splitting it. So this is of course 3 times 3, that's 3 raised power 2. So I want to manage my space, right? So that's going to be 2 log 3 raised power 2. 2 is the power b. 2 log 3 in base y. Then splitting this, okay? So this is going to be minus, of course, open bracket. Because of this minus, I need to use a bracket. Please always take note of this whenever you are simplifying. Anytime you want to split something into 2, it has that what you want to express is a sum of 2, okay, numbers or whatever, 2 times, and there's minus in front of it. Put bracket so that you remember when you open the brackets, the minus will always affect everything inside the bracket, okay? Because if I didn't put the bracket, I will end up, okay, ignoring the fact that minus will affect everything inside the bracket, okay? So now this is gonna be minus, then log, I have 1 all over 3 times this. 1 all over 3 times 1 over 5 is still something, okay? So the 2 log is 1 all over 3 times 1 over 5, which is something else. Log 1 all over 3, okay, excuse me, 1 all over 3, right, in base y, okay? Let me write that very well. Then plus log, okay, so 1 all over 5 in base y, okay? So I don't really have this space, okay? Let me get to, okay, shift a bit so that okay, so with what we have now, we can now do our substitution, right? Remember, log 3 in base y is a and log 5 in base y is b. So I'm having here 4a Here I'm having 3b. Here I'm having 2a minus, here I'm having, okay, what am I even gonna be having here? Okay, a log 1 all over 3. Okay, yeah, now so this is something else. Okay, I have to do something to this, right? So that this is something else, reciprocal of index. Remember, 1 all over 3 something as 3 raised power minus 1. Okay, now this question is somehow very tricky, and of course the same thing goes with 5. 1 over 5 something as 5 raised power minus 1. Okay, all right, and in base y, right? And if we should go by the power law, right? This is going to be minus 1 at the back, right? Log 3 in base y. So then of course this minus also goes at the back. That's minus 1 again. Then log 5 in base y. Okay, so I can now complete my substitution, right? So then I'm having 4a plus 3b plus 2a, right? Minus open bracket log y 3 in base y. Okay, so that's my a. That's I have minus a, right? And minus b. Are we good? Of course, minus a minus b. So this is gonna be plus a plus b. So adding it, plus a to this. Okay, 4a plus 2a, that's 6a, then plus a, minus minus is plus, right? That's 7a. Go to this 3b, right? And of course minus into minus b, right? That is plus b plus 1b, right? 3b plus 1b, that's 4b. So I have been able to prove that relationship. Where is the relationship? 7a plus 4b. So I hope you understand this, okay? But I'm very sure that if you go through this tutorial one more time, you will definitely understand the principle behind this solution. All right, see you in the next video. Thank you very much.